Good evening. Thanks for being here. Hope you all had some pizza, something to drink. I am, as Sudhir said, Tim, and I run the developer relations team at StarTree. I'm going to give you an introduction to Apache Pinot. I have about 30 minutes for that. So why is there a Pinot? It's an OLAP database, like you may know that. I don't want to bury the lead. And it's worth asking, gee, why did we make another one of those? There's a lot of them. Well, there are big things going on in our world, in the world of people who build things out of software. It used to be kind of simple, right? There was a database, it was a relational database, it was the center of your world, you built an application around that database. And the basic architectural paradigm that this borrows from is about 40 years old. It's like almost my age. That's not quite, 80% of my age. And there was a database, you built an application around it, it was easy to think about, you kind of owned the world, it was great. And then suddenly about 10 years ago, 15 years ago, this got a bad reputation. We started calling these things monoliths, and we meant that to be like a bad word, right? And this is a very timely topic because I understand last week Amazon Prime Video said that microservices are bad and monoliths are good. That's what I read on Twitter. So I'm actually going to record a podcast on that on Friday. It'll come out in a few weeks. So shameless plug, StarTree has a podcast. It's called the Real-Time Analytics Podcast. If you want to be friends, you should subscribe. In any case, here we are. The monolith kind of became a bad idea. What was nice about it, though, was that application architecture was understandable. Analytics was a solved problem, right? You had a transactional database, and then you moved the stuff into another database. That was all kind of known. And the legacy data warehouse, eventually, that's kind of an old idea. That gave way to data lakes and all of that kind of set of technologies. Essentially the same thing, though, where you're taking this one source of transactional data truth and moving it over here and then running queries on it. And it was understood, it was good, right? We knew how to do that. Now there is a broad consensus that this is still a thing, right? And it's not like you're somehow immoral if you structure applications this way. It is entirely appropriate sometimes to structure applications this way. That was kind of sort of the discovery of that Amazon Prime Video team. If you actually read the blog post, it's a little more subtle than that, than the hot takes. But there are a couple problems, right? Monoliths didn't handle complexity very well. Software gets big, it's hard to reason about the whole thing. You can't fit the whole program into your head because you're limited in what you can think about. It's slow to test, it's slow to deploy, it can be difficult to scale. There's all kinds of problems there, right? And that way of doing analytics, where here's all the data and every night I'm going to mush it around and put it over here so I can run reports or build dashboards or whatever, put it in the data lake. That is fundamentally a batch process. Over the last kind of 10 years, without anyone really noticing when it happened, that idea of doing batch analytics has become, there's just kind of friction with the way people expect things. And it's a little bit of a cliche, but it's true. I set my phone here for the timer so I can tell how long I'm speaking. But once smartphones became a thing and more and more of our life became mediated through apps on our phone, you actually kind of expect the thing in your pocket to wiggle when something in the world changes. That's just how it is, that you have real-time expectations. And now you, as people who build the systems that cause the wiggles, now you kind of have to build things that are real-time as well, that are event-driven. So there's been this migration to this event-driven world, and kind of a broad consensus now that something like Kafka is where events live, and to some degree the source of truth at the bottom. And at the top, you've got the actual code you write that takes care of people who buy things from your company or people in the business or whatever. The stuff that, as an application developer, you should actually be paying attention to. Differentiated application code. What goes in the middle? Dragons, right? Because in the world of the monolith, you knew it was a database and, fine, pick the language, pick the framework. There's still choices, but you know what it's structured like. With this upheaval, we just don't know what's going on in here yet anymore because it's now unexplored territory. And when you want from that application code to ask questions about what has happened, logs are bad at that. Logs are great at, you scan them, right? They tell you the thing that just happened. But if you want to ask questions, now there's all these weird things in the world that people they're not like bad, these are all great solutions, but we're kind of casting about for how to handle this middle ground, middle section of our infrastructure, and answer the question, what has happened, to get insight into what has happened. Because of this upheaval, because of this revolution, this event-driven revolution, which isn't done yet, we're in the middle, we're living through it, there's this weird space. And that is where, I think, why Pinot exists and why real-time analytics has become a thing. So who does this? Well, it started at LinkedIn, and it kind of co-evolved with early Kafka. So Pinot and Kafka have a fairly intimate relationship in terms of typically, like if you've got Kafka in a system and a database, you'll use Kafka Connect to integrate the two. Pinot is a native Kafka consumer, so there's like nothing else in the world as far as it's concerned. It just eats stuff from Kafka. It was designed at LinkedIn to turn LinkedIn from a site I visit once a month when I want to update my contacts or change my resume, or if I'm trying to get a job, to now, I'm probably not a great example. I'm terrible as a social media addict, but it's a site that's worth visiting all the time because Pinot was built specifically to power dynamic features like who viewed my profile, like the feed and all this stuff. There's all kinds of these real-time analytics queries happening just to load a single page. We're going to hear later about, there's a company, I forget what they're called, but they deliver meals and things. And here we are. So we're also going to hear from Stripe. So there's financial use cases, meal delivery. I think it's like maybe only a little bit of hyperbole to say that on planet Earth, if you want to get a meal delivered, Pinot's going to be involved. That might be an exaggeration, but it is only a small exaggeration. So we got meal delivery. All right, I want to talk about how Pinot's built. I don't want to spend, we don't have a lot of time, but I think it's worthwhile if you're new to a technology and the technology is making bold claims like, we're an OLAP database, but we'll do everything in 100 milliseconds, and you can throw 100,000 queries a second at your cluster and everything will be fine. That's a bold claim. If you are a developer using a database, you need to think about tables and SQL queries, right? It's not, that's the kind of the interesting day-to-day using the product in anger kind of interface is it's tables and queries. You don't need to know how it's built, but for me, when I'm approaching a new technology, to properly form a mental model and have some means of evaluating whether the numbers sound like they could possibly be true, I like to look at what's inside. So let's look at what's inside. We're going to start by ingesting data. And the cool thing, kind of the place where Pinot shows up in the world in an interesting way, typically has to do with real-time data and streaming ingest, and like there's probably Kafka or Pulsar or Kinesis or something like that lying around. Trust me, it's a lot easier if we start with batch ingest. We'll get to real-time ingest, but imagine there are giant piles of JSON lying in S3, and we're going to batch ingest that data. Let's walk through the process. So I've got, by the way, it's clickstream data that I'm ingesting. Could be anything. I like the way that looks on the slide, is really why I picked it. Does not even matter what the data is. We're going to ingest those into a table, which, by the way, we will spend zero further time discussing the Pinot data model because it's tables. And the query language is SQL, like you already know how to do it. So I want to ingest those records into that table. As I do that, and again, this is a batch process, so it's reading records from a file, and every once in a while it'll decide, okay, I've had enough, I'm going to write a segment. And then it'll keep ingesting. If there's more data, it'll write another thing called a segment. And a segment, to a first order approximation, just think of that as a file that's got that collection of ingested rows. We break the data up into segments because obviously now we'll be able to replicate these and distribute them among multiple machines in the cluster. We'll talk about how that works in a minute, but this is how Pinot is going to scale storage and compute, by breaking a table up into segments. So all the segments, and those segments make up a table. A table is stored in segments. What does a segment look like? There's an interesting thing that happens here. So because Pinot is an analytics database, it's an OLAP database, it's not a transactional database, that drives some decisions about how data is stored. And if this is a thing that you know about databases, you know it, but if you've never stopped to think about it or never read about it before, this is an interesting insight. So we're going to read a bunch of these and create a segment file, but we're not going to store all of those fields all together. So we don't take this one entity, or just call it a row, because you could turn that into columns and values. We're not going to serialize that whole row together. That's what you do for a transactional database, because often for a transactional database, you're interested in a particular thing, right? You want to change a thing, you want to read a thing, you want to write a thing. It's that entity that is of concern. Usually with analytics queries, there could be certain columns that you're interested in to filter on. Maybe there you could, let's just say you're going to filter, maybe you'll group, and you want to compute some aggregation. What does that mean to compute an aggregation? That means there's going to be something like bytes here. Let's say I want the average number of bytes for all of the IE6 clicks or something. Maybe there's a couple OGs out there, or a couple of diehards out there still doing it. Well, that means I'm going to need all of those byte values, and I want to read them. I want them all in one place so I can scan them. So I want columns stored together. That's what we do. We read this in, and all of the values of the IP column will store those. All of the values of the user ID column will store those. We'll store indexes in the segment as well for whatever indexes we have defined on these columns. And we'll store the columns together. So this is what it means to be a column-oriented database, or a column store. We store the columns together because everything is hyper-optimized for scanning. There's two things that you have to do if you're a database like Pinot, and that's not scan, right? You could scan less, try not to scan something, and scan faster. So that's what's going to drive your performance, your read performance. And so when we're ingesting, this is how we structure the data. All right, so that's a segment. It looks like that. And again, we have lots of these. They're basically kind of going to look basically the same. I'm sure there'll be some little differences between segment to segment for how the values stack up. But we've got all those segments that make up a table. And we'll take away the pretty colors, just give them numbers now. And we're going to put those on a component in a Pinot cluster called a server. Now, I would remind you, naming things is hard. And this is called the server. Now, there are other components which you may also think are also quote-unquote servers. This is the Pinot account of what a server is. It's where data is stored and where most of the query computation takes place. Servers are, in a sense, the true heroes of the Pinot cluster. That's where data is stored, and when queries are executed, that's where they go. So we'll scatter these segments among the servers, and we can replicate. We can define, I want to make sure each segment is stored in at least two places. Segments are immutable, which makes things like replication a little more pleasant, right? We don't have to worry about consensus on anything. We just have to make copies and make sure there's a copy of things, and life is good. Okay, so there's our servers. Kind of building a Pinot cluster piece by piece here. You've seen how we're doing this batch ingest, how we build segments, where segments go. How do we make queries happen? Well, you got a broker. Broker is another unit of the cluster. That's where you send queries, and the broker has access to metadata to know what segments out there will be able to process the query that you are trying to execute. So the broker will then intelligently scatter that query to the servers that can answer it. Those servers will do the I/O and compute, and the broker will gather those numbers back, and they'll go back to the client. You've also got a box called the controller. That's an Apache Helix controller. That's basically, just think of that as doing cluster management. And there's Zookeeper, where the metadata is persisted because everybody loves Zookeeper. So that is a Pinot cluster. And this ingest is happening constantly, of course. So batch ingest, yeah, you've got all that data somewhere, and you're running a utility that is producing segments. That's either a command line utility with open source Pinot, using StarTree Cloud. It'll be StarTree Data Manager, which you can actually use for free if you really want to. But this is kind of why people come, right? We probably want real-time data and not just batch data. So when we're ingesting streaming data, again, Pinot is its own Kafka consumer, so there's no intermediary, there's no other thing, no connector. It's just, you just hook up the topic, and the fields in that topic will become columns in your table. That topic is consumed and stored into, just think of it as an in-memory data structure called the consuming segment. Now that consuming segment is in memory, and it can participate in queries. So as soon as I have consumed a message, that message can be returned in query results. There isn't any kind of batching or time or anything. Consume it, it's in the segment, you're done. When it fills up, then I dump it to disk and it becomes a segment, and we're going to do that over and over again, right? We'll keep consuming and creating new segments. By the way, you can set a maximum amount of data or time that you want data in segments to stick around, so they can start falling off the edge of the world after 7 days or 10 days or 20 days or whatever you want. Always want to be careful with commercial messages at meetups, but nobody wants to operate this, right? That's a terrible idea. You want to use a cloud service. If you use StarTree Cloud, there's kind of cool support for tiered storage, where your cloud blob store of your choice, I think right now as long as it's S3, you can, after a certain amount of time, store data in S3 with some really neat performance optimizations that make it a lot faster than you'd expect. Obviously, there's a latency trade-off, but there's some cool things that happen there that make that go faster. If you would watch our social media feeds and our Slack space and everything over the next couple weeks, we've got a really great video that I did with Neha Pawar, where we're writing on the glass in midair, drawing pictures, talking about Harry Potter. She's explaining how tiered storage works. She led the team that built it, so she's a good authoritative voice on that. Briefly, indexes. I've got some animations, but I'm going to just stick to a list. We're just going to talk kind of about what your options are, right? If you're a database like Pinot, you have to be able to ingest data at a high rate. That's kind of the idea, right? There's streaming data, there might be a lot of events. I sure hope I can keep up and I can ingest those events at a high rate, maybe 100,000, 200,000 more per second, like whatever that might happen to be in a large system. You have to be good at ingesting data efficiently. That's hard. There are engineering challenges there, but in a sense, that sort of gets you into the game. It gets you to the table. It's not really where the money is made. The cool stuff is in reading, right? And again, these are tables like you're used to. To create them, you don't have a create table statement because everybody's sort of vendor-specific extensions to create table has some bizarre options thing that's 600 pages in the documentation and completely non-standard and everything. With Pinot, we just said, you know what? You're just going to write some JSON. Forget it. You don't need to create a table statement. Write this JSON document. And so the table is defined with JSON. There's another JSON document that defines the indexes. Point being, you define the indexes on the columns that you want, depending upon the kind of data that you've got and the access patterns, and you got lots of options. Forward index, I'll leave that. That's kind of, it's common, but it's almost more for internal housekeeping. The inverted index, that's a way of saying, if I know a value, like, what's my zip code? 80120 right now, not for much longer. What are all of the smart thermostats in the 80120 zip code? That's an inverted index kind of use case. I've got the value, and I want to know what the rows are that have that value. There is Bloom filter, which is a nice optimization that helps a server know whether it should bother looking in a segment for something. It's this kind of probabilistic in-memory way of saying, yeah, you should try looking for that, or no, you shouldn't. We got range indexes. I just said smart thermostats, so imagine we've got temperature readings, and I wanted to be able to do queries per degree or something like that. I wanted to break some number up into ranges. I can do that efficiently with a range index. There's a text index that does all kinds of nice things like regular expressions and prefix searches and things you'd expect to do with text. There's a very sophisticated geospatial index, which is helpful probably if you're a company like DoorDash, because you care about the locations of things that are made out of atoms. It is not a purely immaterial business. So that kind of thing matters. That's worth this more than a 25-minute talk in itself. That's a complex topic. There's a great JSON index. I showed JSON being ingested, but you might have a column that's complex nested JSON itself that you don't want to flatten. You just want to bring it in as a blob, as a text blob. Well, you can index that and do fairly interesting kinds of performant lookups inside that JSON structure. There's a timestamp index, and of course there's the vaunted StarTree index, not to be confused with StarTree. So StarTree is the company I work for. The StarTree index, you got to say them that way or it's going to be confusing. This is, so now you know, this is an implementation detail that has leaked into the interface. That is how StarTree got its name. And normally that's bad, because remember TypeSafe. Remember TypeSafe. What do they call? I remember there was TypeSafe. What are they called now? Somebody see it, right? You don't even know. So they changed that because suddenly strong typing wasn't like the thing they wanted to talk about. In my opinion, I think StarTree is a cool enough name. Even when this isn't the coolest index in Pinot anymore, it'll still be a good company name, I think. But it is neat. Basically, if you know pivot tables in Excel or Google Sheets or something, it's like building a pivot table and saving it to disk. If you've got aggregations that you want to return out of the database and 2 or 3 or 4 columns that might be involved in that query, you can define a StarTree index and it pre-computes those aggregations, so you get insane performance boosts because it's pre-computed that they look fake. You see the benchmarks and you'll be like, they're lying, it can't be that fast. Well, I mean, there's a story there. And it's a great index. These are pluggable, so you don't even need to rebuild the code. It's all Java SPI stuff. So, new indexes can be developed and plugged in, and probably in 5 years, this won't be the interesting story of the indexes. There will be other things that are there. So that's really the deal. You need to be able to read in the ways that you want, and you get to do that, right? I mentioned pre-computing in the StarTree index, but other than that, you're not solving that problem ahead of time. You have to think about your access patterns like any database optimization. You got to know what to index and what your queries are going to be, but you don't have to know everything. It behaves much more like the relational databases we've all been using, and more conforms to those expectations from the API side, from you as a developer using it. It just kind of feels like normal life. And the process of optimizing reads feels kind of more like what you do there, and doesn't push all of that, oh no, I have to completely be explicit about all my reads and pre-compute and throw it in a serving layer. With a good set of indexes and a sensible data model, all that stuff kind of gets out of the way. It's great. Anyway, back to the beginning. The work of understanding how to build systems now that we're in this event-driven world isn't done. That is work that kind of we collectively are doing, and exploring, the space with the dragons. The exploration of that space isn't done. But it's my conviction that in an event-driven world, with something like Kafka being pretty much the consensus standard for where events live, something that makes those topics queryable is probably going to be necessary. And something that makes them queryable in real time, meaning fast enough to return a result to a user synchronously in a user interface, is probably going to be a thing that shows its head as a thing that we need to deploy more and more. So I think it's a good thing to know about. And with that, I say thank you. We've got a Slack workspace. You can ask more questions. Take a picture of that, visit that QR code. Thank you.